Hey, what's up? Let's do a little bit of math today. In this video, let's talk about simplifying square roots. Now, simplifying square roots is when we're dealing with square roots of numbers that are not perfect squares. So like the square root of 24. Now, a question I get a lot from students is obviously how? How do we do this? But second, when am I done? When do I have to do this? And so first, let's address this whole question of when. And so when we have to do this, if there are any repeating factors in a number. All right, so let's think about what that means. If there are any repeating factors in a number. So for example, let's use a smaller number. Let's look at the square root of 8. Well, we could break 8 down as the square root of 4 times 2. And if we want to, we can break that down a little bit further as 2 times 2 times 2. Here, we have some repeating factors. And so let's circle them. We have, actually all three of them are repeating. That's not good. That means that we can simplify this. Now, one thing I like to think is that, or one way I like to think of this, is that we have 2 in to get 1 out. So we take a look at this. I have 2 2's. I can take 2 of them out and it's going to become a single 2. And so this gets us to the how. There are 2 ways we can go about doing these kinds of problems. One way is that we just go to all the factors and we do the whole 2 in, 1 out idea. The other one is look for perfect squares. Perfect squares. And so let's just kind of show you with these 2 examples right here. We have square root of 8, square root of 24. So square root of 8, what I could do is break it down into all its factors. So this is 2 times 2 times 2. Now, in order for, remember we talked about square rooting, is that we're having, I have air quotes going on here, having in multiplication, meaning that we have to have 2 of something to take 1 of it out. So we look for sets of 2. These are now going to go away, but they're going to come out as 1. And so we'll end up being left with 2 square root 2. Here, looking for perfect square roots, what we can do is, let's call it square root of 8, and we can think of this as the square root of 4 times 2. And then if we want to, we can break it down even further, root 4 times root 2 like this. And square root of 4 is just equal to 2, so we get 2 root 2. Either way, we get the same answer. Now, usually for me, it's a convenience factor. What is easier with either of the numbers? Let's do another example. And actually, let's change it up a little bit. Let's go with square root of 12. Now, if I want to do all the factors things, I would break this down as 2 times 2 times 3. Because 12 is 2 times 6, or 4 times 3, however you want to look at it. Again, I need to have 2 numbers, and I can take 1 of them out. And as a result, I end up getting 2 square root 3. And that's as far as my answer can go. Or, if I were doing the perfect square method, again, I'd think of this as square root of 4 times 3. I would realize that this part becomes just good old 2, and I'm left with 2 root 3 again. And so that's what we're doing, is we're trying to simplify these numbers that are underneath, so that way what we have left is something that is we would call a, or it doesn't have any repeating factors in it. And so let's do one more bigger number example just to kind of hopefully make sense of all of this. So now, let me get a new color here. Let's go blue again. Square root of 40. All right. In my mind, I'm going to think of square root of 40 as 4 times 10. Now, 4 is a perfect square. So that's going to make this 2 root 10. Now, 10's a bigger number. We can break it down, but here's the catch. When we break down 10, we get 2 and 5. these are not repeating factors. And those are also prime numbers. We can't break them down any further. So this is what's telling us that we're done. There's nothing that's being repeated here. So now let's look at some harder examples. Leave it at that. So for harder examples, we're going to have a number right here. And the operation that's between the 5 and this root 63 is multiplication. So whatever we take out of here is going to end up getting multiplied to that 5. Now, for something like 63, I look at this as 5 times the square root of 9 times 7. Again, I'm breaking it down to 9 because I know that 9 is, or the square root of 9 is 3. So this will come out as a 3. This disappears, but it's going to be 3 times 5. Big mistake a lot of people make is they add them together. So this is going to be 15 square root 7. We box it, walk away. Here, this one, it's kind of tricky. I'm going to go with 2, 14, 2, 7. So now I'm looking at this as 3 times the quantity of 2 times 2 times 7. So here I'm going to do the 2 in, 1 out trick. Take these two 2's, move them out here, put as 1, 2, and again it's going to get multiplied to that 3. So when I do that, I will get 6 times the square root of 7. Let's keep on going. Now we have bigger numbers. So here's where maybe you don't know your perfect squares off the top of your head. That's okay. What we're going to want to do is break it down into smaller and smaller numbers. Let's get a new color. Let's go red. Okay. So here, I'm going to break this down by taking out a 2. And when I do 126 divided by 2, I end up getting 63. Now, 63 I can break down as 9 and 7. Here, I'm going to stop because I know that, first of all, 7 and 2 are prime. They're not going any further. And 9 is a perfect square. This will come out as a 3. And so what that leaves me with is 3, and then underneath my radical, I still have the 2 and the 7. These are all being multiplied together. So it's going to be 2 times 7, which is going to be 3 root 14. Then, let's take a look at something like 125. Again, break it down into smaller numbers. Here, I know a 5 will come out of it, and when I do that, I'll get 5 times 25. I can pause. I know that this is 5 squared, but actually, let's go a little further. Let's write it out. Now, everything's in its prime factorization, and I see 2 5s that will come out as just 1. So this will leave me as 5 square root 5. Again, box it, walk away. Finally, let's do some challenge problems. Again, these are big numbers, and so you might not know some factors of these right off the bat, and that's fine. So what we'll do is we'll just use some basic division. Let's go, this ends in a 0, so I'm thinking 10 and 22. Now 22 is 2 times 11. 10, 2 times 5. I've now broken it down into its prime factors. You can't break 11, 2, or 5 any further. So what I'm going to do is circle these two 2's, and I'm going to take them both out, but again, it's 2 in, 1 out. This is going to become 1, 2 on the outside, and what I'm left with is 5 and 11 on the inside. So 2 square root 5 times 11, 55. Box it, walk away. Finally, big one, 960. Same idea. I'm going to go 96 times 10. And then I'm going to keep breaking this down by 2. And so 96 divided by 2 is 48. This is 2 and 5. Now 48 I do know as some bigger numbers. Let's see here. 48 is 16 times 3. Now here's the catch. I know that this is going to be 4 and 4. And so what I can do is take out one of the 4's and one of the 2's. And they're going to get multiplied out here. So I'll have a 4 and a 2. That's going to give me 8 plus everything else that I have left. So I will have 8 square root 15. And that is how we simplify square roots. Hopefully this has made some sense. If you have any questions, let me know.